Hello students, welcome to the next video on Analog Electronics 1. Myself Gunjan Mittal Roy in the Department of Electronics and Communication Engineering in GEMTech, Greater Noida. Okay, in the previous videos we have talked about different 2-layer and 3-layer devices. Up till now, in this subject we have covered 2-layer and 3-layer devices. And in this video we will be covering the next semiconductor device category, which is a 4-layer device. And in that category the very first device is called as SCR, which is silicon controlled rectifier, or sometimes called semiconductor controlled rectifier. So it is basically a power device, or it is a device which can carry high power, and it is used for high speed battery switching, and it has a small size and it reduces the cost of production. So the power control devices, which are the thyristor devices, are made up of semiconductor, but they have the capacity to carry high power, high current, and offer high switching speed with the small size and reducing the cost of production. So the semiconductor device which offers all these parameters or features is a silicon controlled rectifier. Although many other devices can also offer these properties, but this is considered as the parent high power device. So the SCR is the most special semiconductor device, and it is popular for its forward conducting and reverse blocking characteristics. So basically it is a device which offers properties in two ways or two directions, which are forward conducting and reverse blocking. It is, again, as I mentioned, it is a high power device, and it is used in CPU and also in SMPS, which is switch mode power supply. Okay, it is a two-state device for efficient power control. Okay, so if we talk about its construction, so it has got 4 layers arranged as PNPN, and it has got 2 terminals out. It has also got a third terminal, which is called as the gate terminal. Okay, so SCR has 2 states. First is high current, low impedance, which is called on state, and second is low current, high impedance, which is called the off state. So the transistor action in a 4-layer PNPN structure is analyzed first with only 2 terminals and then with the third control input introduced. That means initially we will talk about the working with 2 terminals only, and then we will come to the third terminal. This is the VI characteristic, and we will discuss how do we get such operation. So basically, first of all, let me show you its structure. It has got PNPN layers, and the upper terminal is called anode, the lower terminal is called cathode, and the middle can also be used as a gate terminal. If we break this to study better, we can consider the 2 transistors PNP and NPN. If we apply forward voltage to anode and cathode, the anode must be connected to positive terminal of the battery, and the cathode should be connected to the negative terminal of the battery. So in that case, the junctions J1 and J3, if I show you here, okay, so if I say that the first junction is J1, then J2, then J3, J1 and J3 will become forward bias, whereas J2 will become reverse bias. So forward bias junctions have less small depletion width, whereas the reverse bias junction has large depletion region. So this is called the forward blocking state, as the middle junction J2 offers blocking although we apply forward bias, and if this voltage is not sufficient to overcome this blocking, no current will flow. So it is showing here, cross is indicating that until the voltage applied across J2, or until the voltage applied across cathode and anode is sufficient to overcome the potential barrier across J2, the device will remain in blocking state. So this is called the first stage, called as forward blocking state. Now this diagram shows that if the voltage is much higher, which is sufficient to overcome the voltage drop, the potential barrier of J2, so it will also become thin and smaller with the increase in voltages across anode and cathode, and that way the device will be in conducting state. So this is called forward conducting state. So previous one was forward blocking state, this is forward conducting state, and in this state only the current flows through the device. So this is showing the VI characteristic performance of the device. And in reverse bias, if we apply the reverse voltages, the device does not conduct. So in reverse bias, we do not get any conduction through this device. And here is the overall VI characteristics which we can consider for different gate currents. Here if gate current is 0, the critical voltage is higher. So now if we, as I mentioned, if we introduce the third terminal, which is the gate terminal, it is called as the control terminal, and it shows that if the gate control voltage or gate current is 0, the applied voltage, which is called the critical voltage, is much higher in order to have conduction through SCR. But as the gate current increases, if the gate current is increased, if the gate control voltage or current is increased, the voltage required for conduction now, which is the critical voltage, is lowered. And as we keep on increasing the gate current, the anode voltage or cathode voltage requirement is further decreased. So this is the VI characteristics of SCR. Now we have some applications of SCR. Very few important applications are static switch. So it is used as the switch for power switching in various control units. Then power control. Since SCR can be turned on externally, it can be used to regulate the amount of power delivered to a load. Then surge protection. In an SCR circuit, when the voltage rises beyond the threshold value, the SCR is turned on to dissipate the charge or voltage quickly. And next is the power conversion. So the SCR is also used for high power conversion and regulation. This includes conversion of power source from AC to AC, AC to DC, and DC to AC. Thank you so much.